Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Today we will study engineering applications on hyperbola. The first exercise says an architect is interested in designing a thin shelled dome in the shape of hyperbolic parabola as shown in the opposite figure. Find the equation of the hyperbola located in a coordinate system as shown in this figure A and figure B, satisfying the indicated conditions. First, to find the equation, we have this hyperbola. The part of the hyperbola, this is a part of the hyperbola, not all the parts. This is the x-axis and this is the y-axis, and this is a point 8 and 18 lies on the graph of the hyperbola. So it is clear that this equation is in the second case of a hyperbola as we have studied. So the general equation of this hyperbola has the form y square equal over a square minus x square over b square equal 1. This is the general equation of such hyperbolic sector. To find L A and L B, it is clear from the demand that, look here, the vertex of one vertex of a hyperbola is four points above the center. So here is 4. This means that A equal 4, because A is the distance between the center and the vertex. So we have this equation can be reduced to y square over 16 minus x square over b square equal 1. To find the value of p, we need to search for a point on the graph of the hyperbola which satisfies this equation. This is the point 8 and 12, x equal 8 and y equal 12. This means that in this equation we can replace x with 8 and y with 12. So our equation becomes 12 square over 16 minus 8 square over b square. This is equal 1. So solving this equation for b, this implies that b square equals 64 over 8. 64 over 8 equals 8. So b equal square root of 8. Therefore the equation of the hyperbola is y square over 16 minus x square over 8 equals 1. This is the equation of the hyperbola. In the second demand, he wants to know how far the hyperbola above the vertex 6 feet to the right. With the same way, we can graph again this hyperbolic sector. This is 4. This point is 6 6 feet to the right of يعني this is 6 and y. So we need to know y. Again, we can substitute this point 6 and y in the equation of the hyperbola, and to find the value of y. يعني this we can put here y square over 16 minus 36 over 8 equal 1, and therefore y square over 16 equals 1 plus 36 over 8, and this implies that y equal positive root of 16 multiply 1 plus 36 over 8, and this can be solved easily. The second problem, a nuclear reactor cooling tower. This is the nuclear reactor cooling tower. Is a hyperboloid that is hyperbola rotated around its conjugate axis. يعني this means that if a hyperbola rotated about the conjugate axis, which lies on here in y-axis, this we can obtain this hyperboloid shape. These two figures clearly show our graph. The equation of hyperbola is given by this equation: x squared over 100 squared minus y squared over 150 squared equal 1. If the tower is 500 feet, this means that the length, the height of the tower is 500. All this is the height of the tower. 500 feet. This is the height. So if the tower is 500 feet tall, the top is 150 from the above of the center, and this height is 150. The other height is 350. So we can graph this shape. We can write the x-axis. Here is the y-axis, and this is the x-axis. This is the sector of hyperbola, like this, in the xy plane or xz plane, in the xy plane. So he said this length, all this length is 150 feet. So if this point is the center, 0 and 0, the center lies at the origin, then this point we can we may give to this distance notation R1, the radius of the top. Also we can assign for this length R2, the radius of the bottom. So this point has the coordinates R1 as x coordinates and 150 as y coordinates. However, this point is R2 as x coordinates, and all this tall is 500. All this length is 500. This length only 150. So the remaining is 350. But this is the origin under the in the negative direction of y-axis. So the y coordinates of this point is minus 350. Now the demands in this question: what is the radius of the top and the base. What is the radius of the top and the base of this nuclear reactor cooling tower. يعني this means that he needs to know R1 and R2. From the equation of the hyperbola given in the problem, we have this equation, x squared over 100 squared minus y squared over 150 squared equal 1. So to find the value for R1, we know that this point R1 and 150 lies on the graph of hyperbola. Since the point R1 and 150 lies on the graph of hyperbola, then it satisfies this equation. So we can replace x by R1 and y by 150. Substituting in this equation by this point, this implies that R1 squared over 10,000 minus 150 squared instead of y over 150 squared from the problem. This is equal 1. It is clear that we can cancel this with this. So this implies that R1 squared over 10,000 equal 1, and this minus 1 when we replace it to the other side يبقى 1 plus 1 2. يعني this implies that R1 squared equal 10,000 multiply 2, يعني R1 equals 100 root 2 ft. This is R1. Now we obtained R1. To obtain R2, similarly, we can substitute this point R2 and minus 350 into the equation of the hyperbola. By the same way, we say since the point R2 and 350 lies on the graph of hyperbola, we obtain that R2 squared over 10,000 minus we substitute instead of y 350 minus 350 minus 350 squared over 150 squared equal 1. Now solving this equation for R2, it is directly we obtain R2 approximately equals 253.891 ft. This is the value of the bottom base R2. Finally, what is the radius? What is the radius of the smallest circular cross section in the tower? Where is the smallest circular cross section in the tower? This is the smallest cross section of the tower. Why? Because in a hyperbola, the distance between the two vertices is the closest distance between any two points on the hyperbola is 2a, the distance between the two vertices. So he needs to assign the radius of this cross section. Let us define it by R3. So we need to determine R3. To determine R3 by the same way from the equation of the hyperbola, just assign a point involves R3 on the graph of hyperbola. It is clear that the point R3 as x and 0 as y. This point R3 and 0. Since the point R3 and 0 lies on the vertex of hyperbola or hyperbolic shape, so we can here replace y by 0 and x by R3. This implies that R3 square over 10,000 minus 0 over 150 equals 0. This is equals 1 from the equation of the hyperbola. This which implies that R3 square equal 10,000. By taking the square root for both sides, R3 finally equals 100 feet, and thank you very much.